plasmodium organism to live inside red blood cells if they are sickle-shaped? They can't live there. They can only live in the normal ones, correct? So if you're homozygous for sickle cell anemia, probably going to die of sickle cell anemia someday. That puts you at risk. If you don't have sickle cell anemia and you live in Africa, there's a chance that you could end up dying of malaria someday. But if you're heterozygous for sickle cell anemia, you're protected. You're protected from malaria, and you're protected from sickle cell anemia. This is called a balanced polymorphism, and this is an example of a genetic barrier to disease. The Lord works in mysterious ways, huh? I don't know if I'm going to cover the articular system. I'll look at my exam and see if it's on there. I want to get the lymphatic system first. Give me a second. I'm going to grab another. I'm just going to grab this picture for you. Okay, ready? Extracellular fluid has to return to the circulatory system at the end of each day. Work all day long, get into your car, have to adjust your rearview mirror. Link compresses, fluid leaves intervertebral discs. Fluid leaves the circulatory system, accumulates in the tissues. While you're sleeping at night, the lymphatic system is going to return that fluid back to the circulatory system. Plus, the lymphatic system renders surveillance. It helps protect against foreign material. But there's a problem. You see number 4? This is the big problem in the lymphatic system. It's a lethal factor in the spread of cancer. So I want you to think about this next patient. If I tell you that a patient has found on a mammogram a lump in her breast, what's the next thing that we have to do?
Examine her lymph nodes.
Well, let's first focus on that. We'll get to the lymph nodes in a second. Let's focus on that mass that's in her breast, right? We have to biopsy it, right? We have to send it to pathology. The pathologist is going to tell us what? What type of tissue it is. It might not even be cancerous tissue at all. And if it is, whether it's a benign type of a tumor or whether it's something that metastasizes quickly. Let's say it comes back with something that metastasizes very, very quickly. What's our next question or our next step? You said it
Lymph nodes
earlier.
on their arms, right?
Lymph nodes. Because spreading from here to here, very easy, right? Let's say that it has spread to the lymph nodes here. What's our next step?
Surgery.
In other words, my question is, where's the next place it can spread? Sorry? Well, that's what we're talking about. It's already spread there. These are the lymph nodes in the axilla, right? Okay, so in the armpit you have lymph nodes. So assuming that the cancer has spread to the lymph nodes under the armpit, where is the next place it can spread to? It's spread to other lymph nodes in the body. Because you see, the lymphatic system is also a rapid transit for fluid. And you see how easy it would be for cancer cells and the lymphatic, and the axillary nodes to be able to go to other places in the body. So the next question is, if it has spread to other lymph nodes in the body, I'm going to teach you about staging cancers very quickly. How many of you are all aware that cancers have different stages? They're all not staged the same. Bladder cancer is staged by how far it has penetrated the wall of the bladder. Other types of cancers are staged sometimes only by their size. Other cancers are staged only by the signs and symptoms that they create. But some common cancers like breast cancer, prostate cancer, colorectal cancer can be staged in the following way. If the cancer travels to a lymph node and then travels to another lymph node on the opposite side of the diaphragm, that's going to be the stage 3 or stage 4 in that cancer. So therefore, if you have a lump in the breast that travels here to the armpit, and now the cancer is spread to the opposite side of the diaphragm, now found in the groin or behind the knee, now you understand that the 5-year survivability statistics are going to go down considerably. You guys understand that? Mark my words, you're all going to be confronting this at one time or another in your lives, whether it's going to be you or a family member. So that's why I always ask the following questions. When my wife comes home and she says, hey, you know that person that we had lunch with the other day has cancer, I always ask the following questions. If they get it biopsied, how do you know? They got it biopsied. Did it go to the lymph nodes? Yes, it did. Did it spread to any other lymph nodes? And when she pulls out her little piece of paper, she says, yeah, it spread to other lymph nodes in the abdomen. You guys all from your anatomy class know that the diaphragm is right here, agreed? Right. So once you spread from one set of lymph nodes to another set across the diaphragm, the survivability statistics are very, very poor. What do these lymphatic vessels do? They have these little valves, and this is what basically is going to allow fluid in the tissues to get back into the lymphatic system, and then what happens is these lymphatic systems go back into, say here, yeah. Here's a right lymphatic duct, and here's a thoracic duct. So here are ducts that allows the fluid from the tissues that got back into the lymphatic system to get back into the circulatory system. If you have cancerous cells floating around in the lymphatic system, where are they going to end up getting drained into? The bloodstream, facilitating the spread. So the lymphatic system is helping you every day, but at the same time, it's one of the lethal factors in the spread of cancer. See these lymph nodes in the axilla, right? I think I already told you this. That if your name is up on the board to assist in an axillary node dissection, you're going to be there all morning or all afternoon. You can't go in here with a pair of scissors and a knife. You understand that, right? What's inside the armpit? Okay, blood supply. What else is in the armpit? Anybody ever heard in your anatomy class of something called the brachial plexus? There's a nerve plexus. The nerve plexus is intertwined in this tissue that's in here. You can't just start snipping out axillary nodes. So it takes a long time to dissect them. We'll talk about blood a little bit. So you know that your blood consists of plasma, red blood cells, white blood cells, and platelets. What are the platelets used for? Nobody knows, huh? Clotting, okay. White blood cells are used for what? Fighting infection. Red blood cells are used for what? Good. All right. This isn't any point that I do have. This one I want you to see. These are platelets. These are what platelets look like when they're coursing through the bloodstream. As soon as you tear a capillary, an artery, or a vein, or a venule, or any of these vessels, a chemical is released which causes these platelets to do this. So what they do is they have these protein arms that reach out, grab each other. Now all of these guys, which were all individual, now are forming one clot, which hopefully can't fit through the tear in the capillary or the artery or the vessel. Make sense? So this is what Carol does. She cuts herself. And every 10 seconds, I'm still bleeding. Oh, yep, still bleeding. What is she doing every 10 seconds? Tearing away the clots, ripping away the clots, ripping them away. I say, keep doing that, and pretty soon you're going to get dizzy. It's not the truth, it'll eventually clot. But I said, you know something? What I do is I go to the stove, I put 8 minutes on the stove, and I go, don't you take that off until that rings. And it's like she just can't take it anymore. She just wants to look, she wants to look. Then 8 minutes, she tears it off, and it starts bleeding again.
But that's external bleeding, right?
Internal bleeding as well. Yeah. Internal bleeding would be bruises. And internal bleeding in the abdomen. Who knows how many times you've had maybe a little capillary rupture or a little vessel rupture? Not a big vessel. I'm not talking about the mesenteric artery or the splenic artery or anything like that. Same thing. It's little clots that do it. So let's talk about some of these white blood cells. We need to talk about these 4. They each have different roles. One of the things that you need to know from this piece of paper is that everything comes from one hematopoietic stem cell. An undifferentiated hematopoietic stem cell, which is made in the bone marrow. You take this stem cell, you can, in theory, put it anywhere, and it will take on the role and function of those cells. In theory, if you take this stem cell and put it in the heart, it will turn into heart muscle. Take this stem cell, put it in the spinal cord, it will grow into a neuron. That's what's the big deal with stem cells. It's undifferentiated, it's capable of doing anything. You don't need to know these intermittent cell names. Is that fair? But you do need to know the final result and what they do. So these are red blood cells that one time came from stem cells. These are platelets, which are used for what? Clotting. Okay. You can name some drugs that will keep this process, this clotting process, from happening. Starts with an H, one that starts with a C, one that starts with an A.
Yeah, the one that's really
There's one that starts with an A.
Yeah.
Aspirin. It's a thromboxane A2 inhibitor. Okay? We'll have people chew an aspirin a day, 81 milligrams every single day, to keep them from forming clots, causing a stroke. Another one stands with letter H, heparin. Another one, Coumadin. Okay, these are all anticoagulants. But you learned one other than those? What's it called?
Heparin.
There's one called Lovenox, clopidogrel, a couple of others.
Can't we just chew some willow bark?
I'm sorry?
Can't we just chew some willow bark instead?
We could, only I can't find willow bark in the pharmacy. Okay. Next, these white blood cells right here, we're going to learn them right now, learn what they do. So neutrophils are phagocytes. Do you guys know what phagocytes are?
They eat stuff.
They eat stuff. They engulf and eat stuff, yes.
Are platelets similar to like blood thinners? Like in like the opposite effect, because you're like, oh, what's something that?
Yes, did you know that in order to reverse heparin, you use protamine sulfate, which it itself is an anticoagulant? Is that what you're referring to, or no?
I think, yeah.
Okay, so did you know that there are 2 anticoagulants that you give together and they cancel each other out? Heparin and protamine sulfate. So again, these are for clotting. So neutrophils are phagocytes. Eosinophils are white blood cells that are basically used, when I say used, they're typically implicated in allergic reaction and an inflammatory process. So I want you to think about eosinophils and allergic reactions, but also, do you see this right here, eukaryotic infections? Specifically, worm infections. You'll typically see a high eosinophil count. So what's a WBC, a white blood cell count, right? White blood count? So white blood count, they tell you how many of each of these they have. When you see this number high, you should probably walk into that patient's room and say, hey, look, don't freak out, but here's some medication to help kill the worms. They're going to say, what worms? You're going to say, well, those worms. Yours. So eosinophils, typically eukaryotic infections. Basophils, I want you to definitely think about basophils and mast cells in the allergic response. Right, so when we talk about allergies, we're going to talk about basophils and mast cells. Eosinophils are for worm infections and eukaryotic infections, and neutrophils are phagocytes. So when we come back, I'm going to show you, let me do this. Let me do this right now. It'll be fun. Hold on, let me. Watch this movie. Here's a macrophage. Did they say phagocyte or macrophage? Okay. So it's a phagocyte, and this is a micropipette. This is under a microscope. And this pipette is going to pipette some foreign bodies into this environment and take a look at how that thing moves. Isn't that cool? Like if this is my hand right there, it's going to eat it, right? And watch when the micropipette moves somewhere else. Look at it. Isn't that cool? Isn't that cool? It's like a pet. Sit, stay. Isn't that cool? So hold on, one more. Here's another cool one of a phagocyte. And there's a neutrophil, right, which is a phagocyte. Look at these bacteria. Do you agree that there are some bacteria that are motile? Mm-hmm. Okay. These are red blood cells, and here's some bacterium. Watch this. Isn't that cool? Isn't that cool?
It's like a zoo.
Yeah.
I know, is it gonna get it?
I should shut it off before you get. That's the sound of it burping. Okay. So isn't that cool?